the main reason for this session today is just to have a brief, maybe just a quick overview of what we did last time. And if there's anything, if there's any question that that you have, we can also try to help each other and address that question. But also there's something, there's a concept I would like us to review, which I think will be very important moving forward to the next class that will be on data cleaning next week. So it's a concept on vectors and matrices and how we can actually have some operations to do with data frames. This is just a brief overview so that come next week when you have the data cleaning session, you can have a good idea, or at least you can grasp some of the concepts that will be done there, or some of the concepts which you already covered in the introduction part of the course. But otherwise, first of all, I would like to reach out in case there is any question that has arisen or arose from the last session that we had last week. If you have any question, you can feel free to type it in the chat, or you can unmute yourself and ask the question. So feel free to actually type it in the chat, and we will address the question as we proceed. So now there's a very interesting concept I would like us to talk about, and this is a concept that concerns vectors, how vectors are created in R. So please let me just share my screen and just start. So now this is an empty R script that I'll be using, and we actually saw from the class last time is that the way you can create a vector, you can just say C. Maybe if if it's a vector of numbers, then that you can actually run it. So that's just one way that you can actually create a vector. This C basically means combine or concatenate. And there's also another way. And remember, we have been saying that vectors have to be of the same data type. Very important when you're dealing with vectors. So it has to be of the same data type. That's just a simple vector. Okay. Now, and we also say that if you would like to access elements of a given vector, we actually use the square brackets. Okay. And remember, let me just put a comment here. Indexing in R starts from 1, okay? Or rather, starts at 1. Unlike other programming languages like Python or C, they normally, or C++, they start at 0, or MATLAB. But for R, the indexing starts at 1, okay? What was covered last time is that we said that if you would like to access elements of a given vector, we need to have the name of that vector, then followed by the square brackets and the index or the position where you want to do this. So in our vector here, we can see that this vector number 4 is at position 1, 2. So if I click, if I write 2 and run this line, you can see that in my output here in the console, it's given us as 4, okay? That's how we have been able to access. If, for example, let me just copy this just for argument's sake. Let's say I want to access number 6. So number 6 is in the 4th position. And if I run that line, you can see in my console, what I'm getting is 6. Okay, that is just one way that you can access individual elements of a given vector. We use the square brackets. Okay, now let me also just because we're just trying to review some of the concepts. Suppose I have another vector which has strings. Let me say this is A. You can have B. Just a simple string before now we go to data frames. Then we also have D and E as well. Okay, we can run that vector, and if you look at if I want to run it, let me just. You can see that in my console, there's that output of that vector. Okay, again, it's still a vector that has 5 elements. How do you know the number of elements in a given vector? You don't need to go counting each and every one of them. You can just say a length of the vector that you want, then you run that line. Then in the console, it just shows you that the length is 5. Okay. Now, suppose I would like to access A, C, and E only from that vector. How do I go about this? One way I can do this is that I can say, because first of all, remember, we are accessing elements of that vector. So we need to use the square bracket, individual elements. Then, because now these are not successive elements, what I can do, I can the elements that I want to access, and let me just put a comment here. I want to access A, B, A, C, and D. Okay, so it means that I need to know their positions in this vector. So I can see A is number 1, so I can have that. I want the first one. Then I want C. C is number 3. Then I also want 5. Okay. So what this actually means is that I'm just creating a vector of the individual elements that I would like to access. Okay. And if I run this line now, what it does, and you can see in my console, is that I have A, C, and E, and that was, oh sorry, not D, it was E, and I have my wish there. So it's at least when you want to access elements of a vector, at least have an idea of the position in that vector. Okay. Now, the other thing that we can also do is that in my matrix, in my vector here, suppose I want to access all the elements except the first one, the first element, or the first item in that vector, in my vector W. How do I go about this? Because now I know the position of the first element, which will be index 1, what I can do, I can just say -1 like that. So this one, R will interpret that you want to return all the elements in that vector, that is B, C, D, and E, except the first one. Let us run that line and you see. So you can see from our console here, it has returned B, C, D, and E. So -1 basically means that what will be returned will be all the other elements except the first one. Okay. Then, just for argument's sake again, suppose I want to remove C, D, and E. I want to remove all those elements. What can I do? I can still, because I want to access the individual elements of that vector, I can say -3. Okay. Then because there will be successive elements in that vector, I can use a full colon to show that I want this to be stepwise until it reaches the fifth element. So -5. So this what R will interpret in this is that you want to remove the elements from index 3 to the fifth index. Okay. So once you run this one, you will see that what is returned in the console is just A and B from this dummy vector that we have here in line 8. Because now MATLAB now says that, okay, I can see you want to remove the third up to the fifth elements of that vector. Okay. There's also another way that this can be done. We can say W. I can come and call my vector. Okay, this one now, if I call and you can see from my output, this one only accesses elements from index 3 to 5. Wonderful. Okay. I know some of you may have done this, but the reason why how to deal with indices is very important. It's a very important concept because whatever you do for the vectors and matrices is the same concept, the ones which are applied to data frames. So it is important that you have an idea of how to access those items. So as I said, I would like to redo line 14, but using this concept in line 16. So what can I do? If I put a negative before that vector of concatenation, what this returns, it returns the same thing as line number 14, okay? And maybe let's play around and say equals to this. Is it equals to that? Let's see. Yeah, it's supposed to actually return to us true, but that's just another way of dealing with those elements. Okay, that's just one way of creating matrices or of creating vectors. Now, since vectors are supposed to be the same data type, we can also exploit another function which is called sequence. So, for example, I can say A equals to sec and 1 to 15. So this sec, what this one does is that it creates a vector from 1 to 15 incremented by 1 okay? So if I run this, let me select A, and the beauty with R, you can actually select a portion that you want to actually output in the console. So and you can see in this case, it has created, just by using sequence, it has created for us a vector that is being incremented by 1 from 1 up to 15. Okay. So you may ask yourself, if I'm using sequence, does it mean I only have to increment by 1? No, you don't have to increment by 1. You can also do this. Let me create B and say it is sequence. Just quickly, I'm just trying to wrap up this so then we can move to the to what I actually wanted to cover today. Then still the same, 15 and 2. So let me explain what this does. From this one, the first element in that function, that is the start value. The start value. What follows is the end value. And lastly, what we have, that is what we call the step or the incremental value. Okay. So if we run this, and let's see let's output B and C. You can see B, what it has done, it has started at 1 and incremented by 2, so the next value becomes 3. After 3, it has incremented by 2, so the next value is 5, and etc. until it reaches the end value. That's another way that you can actually create vectors, as long as they're the same data type, and there has to be a rule that has to be applied in that. Okay. Another way, although I really don't fancy this function, it is what is called the rep function. So a rep, let's say we want to have C, and it's rep. What you can have 3 and let's say 10. Rep is useful, yes, in some cases, but you'll find that in most applications, this way of creating this vector is not really common. Okay, because what this does is that it says that you repeat 3 10 times. You repeat 3 10 times. So if we run this, let me also put this. You can see from our console here is that it has repeated 3 10 times. Okay, so these 3 are just a way, and it doesn't mean that this one has to just be an integer or a number. It can also be something like a string. So let's say something like, I want to repeat B how many times? Maybe let's just say 5. Okay. If you run that and do that, you can see that it creates a vector of strings where B is the value which has been repeated 5 times. Okay. So please remember all this, because now I want to show you something that we call, or the reason why this. Let me just we say vectorized, and it's also a very important the vectorized operations. So what are these vectorized operations? Okay. Now there's a reason that we do that, why R sometimes becomes one of the efficient ways of efficient applications to handle vectors, is because of this how it handles vectors, okay, and vector operations. Now let's say I have n equals to something like, just for argument's sake, let me say 100. Okay, then I would like to create just random numbers, 100 random numbers, okay, normally distributed. Okay, so what I can do, let me say I have R equals to R norm. So this one is in base R, and it means that you can actually, it's a normally distributed random numbers. Okay, and for this case, I just want to generate 100, which will have a mean of 0 and an standard deviation of 1. Now let's not go into that first. So I just want to generate 100 numbers. So I can say n. Okay, I want to generate n. Then I also want to do p, just another random numbers, also 100. Okay, this is where now the power of R comes in, because if I want to multiply the elements of these two vectors, R and P, what I do, I just come and say R multiplied by P, sorry, lowercase. Okay, so if I run this, and I can just output X, you can see these are just numbers which have been multiplied, but there's something I want us to see. Let me, so this operation here that you're seeing here, let me just do this. This is called a vectorized operation. Okay. R has optimized way that it handles such an operation. Okay. Now, let us look at what is called the vectorized, as in now you deal with elements of each. You deal with elements of R, you deal with elements of P, and multiply them together, okay? But now in a devectorized way, whereby you're dealing with each and every element. Remember now we have just multiplied vectors upon vectors. Now let us look at how you can actually multiply elements in this, okay? Element-wise, that is for R and P. So, okay, first of all, just to go back, we can also remind ourselves about loops. Suppose I can say for I in maybe 1 up to something like 5. What do I want to do? I just want to say print R for fun club members. So just something like this. Okay, this is what I just want to print. Let's see what this gives us. So if I run this, you can see it has printed R for fun club members 5 times. Okay. So what this actually means is that for I, so it picks 1, runs it, goes to 2, do it again until it gets up to 5. Okay, that's just a brief review of loops. But now here I want to access elements of R and P and multiply them together. Okay, but before I actually get there, let me just create. So this is sorry. Now this is the vectorized operations. Actually, these concepts are very important because it just gives you an idea of how to deal with elements, even if they are in a data frame. Okay, but just having the basics or the concepts as to how to handle those elements, that's always a very important aspect. Then let's see. Now, what I can do, I just need first of all to create. So I can just create a vector that has elements in it. So in this case, I can say rep NA is not a number, and I want it repeated n times, just from the rep way of creating vectors. That is line 27. So and it's true, if you actually run this, what you see, you will see that D is just a vector that has NA 50 times. Oh, no, 100 times, because n is 100. Okay, this is important because what we have done, we have just created a dummy vector that can be populated with new elements like that. Okay, now this is where the fun comes in. So I can say, I can now put this in a loop for I in 1 up to n, because our n is 100. That is so 1 means we want to start at 1 and n at the nth value. Okay, but what do I want to do? Remember what I said about accessing elements of a vector. So I can say di, this equals to ai multiplied by, sorry, this is, I want to use R and P, like that. So I want to tell you that this operation that you see in line 47 up to 49, whereby I'm looping from values 1 up to n, is actually the same as this one, which is given line 41. So you can see R has simplified with its vectorized operations. It has simplified how we can do vector multiplication, addition, and etc. Okay. Now this is not even the fun bit of it. Let us run this and we see. Yes, it has finished running. So let's see our D now. You can see. Let me just This is our D now, our new D, after running this and updating the D, which is here, okay? But you may be asking yourself, why am I doing this? Okay, let us see what we call the computational time that it takes to do line 41 and the time it takes to do line 47 up to 49. And basically, essentially, they're just doing the same thing, okay? But only that one of them is efficient, okay? And this efficiency is only realized when you actually have huge data sets, okay? You start now seeing the problem of computational complexity, where your computer now starts lagging because that data that is handling is not handling it in an efficient way. From a concept that we did last week, I want us to do something that is called, we can do Pacman. Do you remember Pacman? Because we want to, and payload, if the package is there, TikTok. This is a package, that is used to measure time usage of operations. Yeah, you can just see that, okay? So TikTok basically means we would like to start, we can say that this is our tick. Let's call this operation 1. Let's just call it operation 1, and we want to end TikTok. We want to end that timing. So we want to time how long this process takes, and then we can actually do the same thing here. We can do the same thing here and say tick operation. Let's call this operation 2. Then we want to end it there. We just want to time it up to that point. Okay. Now let's see. Let's run this, and we see. Okay. Let me also clear my console. If you want to clear your console, you just press Control L on your keyboard. Okay. Control L clears the keyboard, and let me just paste for you in the chat some of these operations to clear the console. Just do Control plus L. Okay. If you want to clear, so you can just take note of those shortcuts I'm pasting in the chat to clear the environment. If you want to clear the environment of any previously used variables, what you can do is we do rm equals to let me see, I just used it previously. Sorry, this one here. This one. Yeah. Yes, this one, rm list equals to ls, like that. If you want to clear the environment or to clear the console. Yeah, those are just some tricks you can use. Okay. Now, I want us to time this first operation. Remember, I've started my tick at the beginning of that operation and talk at the end after the multiplication has already been done. Let's see. If I run this, you can see it has actually used 0.01 second to run this operation. Okay. Now, let's see how long it takes to do the second operation. Okay. The second operation takes 0.04 seconds. So you can see, just from this simple example, it shows that if you decide to do things in a devectorized way, as in you are dealing with individual elements of the vectors and loops and all this. From this simple example, it shows that you are likely to spend 4 times the resources needed. And what are these resources you're talking about? Resources we can talk about the time usage, memory usage of your computer, and storage units. Okay, so it's all this coming together. So you can see R has actually simplified our operations in a way that some of these operations are actually optimized. Okay, and just for argument's sake, let us increase our N to be something like 1000. If we run this, let's see, again, still using 1 second, but how about the other one? The other one can actually take even longer. You see, it has taken longer. By increasing this to 1000, the vectorized operation has just taken 0.1 second. But the other one has actually taken, we can actually say it's just about 4 squared because it's 16 times more. Okay, so you can see for the case when you'll be dealing with huge data sets, this is likely to be a very big problem. Okay, and that's why the vectorized operations are highly discouraged when you're dealing with huge data sets. Okay, and in any case, if I'm able to just do this and get what I want efficiently, why should I bother to do all this? Okay, well, it gives you the same output. Okay, so this is a very important concept, and it just gives us the motivation as to why we need to be using what is called vectorized operations. Okay, and why getting to know elements of a vector and how to deal with the elements of a vector, why that is a very important concept. Okay. Any question after that? If you have any question, you can post it in the chat. I'll try to answer after this, or you can also post them in the Art for Fun Club wall on Afredac. Okay. Now let us look at some operations. I know Chioma covered this last time. I would like us to also do a review of data frames. I would like us to do a review of the data frames and why it's really important to understand the structure of a database of a data frame, because that will determine everything you do about it. Understanding the structure, understanding the data types of elements in that data frame, because that's the only way that you can be able to actually do efficient visualization, cleaning that data, mutating in a very efficient way. Okay, and I'll just start with a very simple data frame. So it's just a data frame that has vectors. So this one can be, we can have Alice. We can also have somebody by the name Bob. And I actually don't know why people always use Alice and Bob when they're giving examples of data frames, but so you can have Charlie and maybe somebody by the name Diana. And you can see names, we have created it using a vector. Okay. Now let's create the other component of that data frame. We can have their edges. Okay. Their edges, we can have now this in numbers: 25, 32, 28, maybe even 45. Okay. So Diana is 45, Charlie is 28, Bob is 32, and etc. Okay. Then what I need to do, I can just have the exam scores. Maybe it was an exam, and they scored this. So you can have 88. Somebody scored 92. Another person scored 85 and 96. Okay. That's a simple, and we can say, we can just call these students. Students equals to data data.frame, and the good thing with R again, it suggests for you the function to use. In that case, I can just choose data frame. What do I want to do? I want to have, maybe I can call this a column, name equals to names. So it will pick names there. Then the other, I can call it age equals to ages, like that. Very good. Then we can just call it the score, the scores. And this is scores, we can just have it as, yeah, like that, exam score. So that is just a simple data frame that we want to use, okay? If I run this, ages not found. Okay, I see. I did not run the other lines as well. Let me just run that. Yes, now it's appearing. So if I want to see my data frame, you can see it has created a data frame with name, age, and scores. Okay, it's a simple data frame. Okay, now we can do, if you want to investigate the structure of this data frame, you can look at it and it will tell you that the names, the column which is given by the word name is their characters. That is Alice, Bob, Charlie, and Diana. A column which is called a name, it says those are numbers. Scores are also numbers. That's just to show you the structure of that data. And sometimes you can do the summary of that data. Okay. And for the summary, for the first column, those are just characters. It tells you the length is 4, and it's true because there are only 4 names. And the class is character, and the mode is character. But when it comes to ages, because these are values, it can give you the median, it can give you the mean, it can also give you third quartile, the first quartile, and also the maximum age and the minimum age. Okay, so this is just a summary of that data frame that just gives you an idea of how these elements in these columns look like. Then we also have the scores column. The scores column again, it can give you the minimum, the first quartile, the median, the mean, and etc. Okay, and sometimes you may be interested just to see the first rows of that data frame. So you can get, but for this is just a small data frame, so maybe it should just give us everything. But if it's a huge data set, maybe it can just give you the first 5. Okay, but we can always you can also give the number of the rows that you want to see using that head function. So if I do this, you can see, as I say that n equals to 10, you can see that it has only given me the first row. Okay, so when you have a large data set, you can maybe even be giving 100. I want to see the first 100 rows. Okay, that can be the function of head. Okay, maybe you're interested in knowing the column names of that data frame, and this is important because sometimes you may actually need to use the header names or the names of those columns. So this function can help you to look at the names of those columns. And in this case, after running, you can see its name, age, and scores in the right format. Okay, and you know, when you're dealing with data sets, there comes a time where you realize that there's an error that you're getting, but maybe it's just the names which you've gotten wrong, and you find that maybe it was scores underscore, but for you just picked scores. So call names just helps you to quickly get some of those column names. Okay, now this is just a brief exploration. So this just helps you to briefly explore the data frame. Okay, now let us now try to look at how you can actually access accessing the elements of the data frame. Okay. Our data frame is students. Okay. Our data frame is students. And suppose Chioma showed us that if you do students and the $sign, and in fact, once you just type the $sign, you'll get a prompt. Which column do you want to select? So in this case, let me select age. If I run that command, you can see that in my console, what I've been able to retrieve is just the age, okay? The ages in that data frame, okay? Now, is there another way that I can access elements of a given data frame? Yes, as long as you explicitly know the name of that column, it is possible. So you can do students in this case. Remember the square brackets, because now the difference between a data frame and a vector is that a data frame now is two-dimensional. And since it's two-dimensional now, it means that elements of a particular column are one-dimensional. So we can still use the indexing strategy to access some of those elements. Now, in this case, I can actually give the string or the name of that specific column. And if I do this, you can see age has been returned there. So now, a question I would like to ask you: what is the difference between these two? Please type it in the chat so that I know we are together. What is the difference between these two? And remember, both of them have given the values of the same column, but what is the difference? Please type in the chat in the next 1 minute, then I'll give you the answer. What is the difference between these two? Please type in the chat. The difference between these two. Okay, I will tell you the difference. Oh, Dr. Omar says the square bracket gives the order. It's close, but that's not what I'm looking for, but it's close. Let me tell you the difference between these two. When I use the $sign, if you use the $sign, what the $sign does, it returns a vector. If you use the $sign to access that column, that returns a vector, okay? But if you use the square bracket, this one returns a data frame. And it's true because if from line 76, if I run line 76, or let me just clear the console so that we can be at the same page. I've cleared the console. So if I run line 76, what it does, and you can see, it has actually returned to us a vector in that structure, okay? But if I run line 78, you can see it has actually given me that in terms of a data frame. Let us compare this. Let me actually also output the student. You can see the student is a data frame, okay? But when I access specific element or specific column using the square brackets, I get something that's of the same structure as my student's data frame. So when using the square bracket, that returns a data frame, but when you use a $sign, that one returns a vector. That's the difference, and there's a very important difference. Okay? Yes. Now, having said that now, suppose I would like to access only the second row. How do I go about it? I just want to access the age of Bob and the exam score for Bob. Only that. That's what I want to access. Okay? Now, remember, as we said that now, this is a data frame and it's two-dimensional. So if it's two-dimensional, you have to think about, let me just say, rows, that's the first position, and columns like that. Okay. So what do I need to do this? I know the index here in the second row is given as 2. So I can do 2. That gives me the row. But if I do this, this may not be, in some cases it may work, but it may not be the correct thing to do. Because now, if I do comma, okay. So if I do a comma and just leave a space there, what this means is that I want to access, so this means, let me just put, that is, in this case, I want to access row 2 and all the column elements, in that row. In that row. That's what it means if I actually do this. And if I run this, let's try. You can see that it has only returned row number 2. Okay, row number 2. Now, here comes the question. How do I access Bob's age? How do I access Bob's age? Please type in the row in the chat. How do I access? Now I've seen that if I do students square bracket 2 and a comma, it means that I am accessing row number 2, but all column elements in that row. That is, I'll get Bob's age and I'll get Bob's score. Okay. But now, because now I'll start it for you. I already have Bob's row. How do I access Bob's age? Please type in the chat the next 1 minute. How do I access Bob's age? And please think of it as rows and columns. Okay, Basil has said 2. We'll try that. Yes, Dr. Mar, that's correct. But now, how do I input that in my square brackets? That's what I'm asking. Basil, you have said 2. Let's try. Let me put 2 and we try together and we see what that gives us. It's true. 2 can actually work. Why? Because Bob is in row 2, but the column for age is in column 2. So that's correct. That can work. Suppose that is one way to actually do it. Then suppose I also do this. I say, and I also put age like that. Will I be able to access Bob's age? Let's see. Yes, we'll be able to access Bob's age. Okay. So these are just 2 ways that you can do this. As long as you know the index of that column, you can still do it. Okay. If you know the name of that column, you can still use that to actually access that element of that particular, that individual element in that column and that row. Okay. Now, another question, and you can type it in the chat, because actually knowing how to access these elements in a data frame, it is very important because that's one of the foundational pillars of data cleaning and other aspects like visualizations. Okay. Now let's see. In this one, I want to access only the first. I want to access only the first 3 rows. How do you do that? You can type in the chat. How do you access the first 3 rows in that data frame? And as always, think in terms of vectors and think in terms of rows and columns of that data frame, because now this one is 2-dimensional. Okay, you could just take any guess and just type in the chat so that we can all learn together. You can type it in the in our chat. What do you think? Students -4. Interesting. Let's Dr. Omar, let us try what you've typed there. If you do this, what does it do? It still returns to us the whole data frame. Okay, let's try and add a comma just for argument's sake and see whether that works. Have you seen that that change, Dr. Omar? Previously, you did not have this this comma, and you were just saying you want to access everything except the last row. But now, remember, students is not a vector. Students is a data frame that is 2-dimensional. So you needed to put that comma so that R can understand, yes, you want to access students, but also as you are accessing students minus the last row, you also want to access all the columns. Very good. Actually, this is a I've never used this, but it's great that you've actually seen it. Then there's also another way that we can do this. We can do students. I can say I want to access from row 1 up to row 3, and I want all the columns as well. Okay. So if you do this, you'll find that we get from Dr. Mar's suggestion, we get the same answer. Okay. Very important strategy when you want to actually access elements of data frame. Okay. Now, I know that I have already created my data frame, which is students. But suppose I know that there's 88, there's 92, 85, and 96. Suppose I want to actually add their grades. Okay. What can I do? I can do a students, but since I want to add the grade, what this does, once you do this, this one creates a column in that data frame that is called grade. But what do you want to do with grade? With grade, I would like to actually populate it with grades of the students. And this one will be a string. I can say this is A, there's a B, and maybe also another A. So if I do this, what actually happens is that this one, creates a new column called grade, and a new column called grade, and it is populated by the string values listed. String values are listed like that. So, and if I now want to check students, you can see now the new data frame has grades. So you can see name, age, scores, and grade. Okay, and that's another. Oh, sorry. That's another way we can do this. And suppose I have realized that maybe Charlie's age is not 28. I would like to correct that error and make sure that Charlie's age is something like 45 years. What do I do? What I need to do, I just need to find a way of accessing Charlie. Charlie, we know, is in row 3. So 3. So there's a way Basil showed us how when we were looking at Bob's age, that is line 82. So we can actually do that. But also, if you have the name of the column, you can just do age. But now I want this to be assigned a new value, 45. Okay. So if we run this and come again and run the students, you can see that now Charlie's age has been updated to 45. Okay. These two are just ways, one of the ways that we can use to modify an already created data frame. Okay. Then now what can we do? So we have seen how we can add a row, a column, how we can modify a value. But suppose a new student joins in, okay? And this student is by the name, let's just call her new student. So we can have our data frame now become as a new student. So data frame, because now this will now leads us, it can lead us to one of the ways that you can actually join. One of the simplest ways to join the data frame. And the student's name, first of all, is we can call her Eva. Eva has the age of maybe 23, and her score, or rather her scores, equals to maybe 90. And this from the way we grade them, this one will have to be an A. Okay, that becomes a new data frame there. Okay, you can see. So this is name, age, scores, and grade. But we want to append our data frame. So what can, and this is the row. You just want to add this row to an already created data frame. Okay, so we can just simply use rbind. So students will be equal to rbind. What are we binding? We are binding our data frame, the one which is called students. What are you adding at the end? What you're adding at the end is new students. Okay, new students there. Okay, so what becomes of this new data frame? So if I run now our new students, that becomes, you can see now we have added Eva in our updated data frame that includes the age, the score, and the grade. Okay, now for data frames, it does not mean that all you'll be doing is just adding. Okay, we'll also see how you can actually remove a column how you can remove a row and etc. But before we actually go there, because we have already a good data frame, let us try to see how we can actually sort some of the values in this data frame. Sorting the data frame. And this is actually, let's see, we can call this, we can sorted maybe by, let's just call it by age. So how can you do this? Now, when you're sorting, MATLAB has, R has a function that is called order. And the default for order is always ascending. Whose default is always ascending. So once you do ascending without specifying anything, once you use order without specifying anything else, R will just interpret that you want this to be in ascending order. Okay, so let's go. What do we want to sort? We want to sort our students' data frame. Okay, now what do you need to sort this data frame? Now we have the data frame, but now we need to access the specific item that you want to use in sorting. So I can do order, but what am I ordering? I'm ordering students, but I want to use the age. I want to, as I'm ordering, I want to order the age. Okay, and likewise for all columns. Okay, so if I run this, what does it say? Remember, our age in our students data frame is given as 25, 32, 45. So at least if it's ascending, we expect the highest, Charlie and Diana, to be the last because of their ages are bigger than the rest. And you can see, so it means that now, if I just do this, it has sorted now 20, according to the age, 23, 25, 32, 45, and 45. Okay, according to the age. Okay, you can also decide that now you want to sort by, maybe to sort by score, because those are the only by the scores. If you want to sort by the scores, you can do students. Again, what do I want to sort? Now this is something we'll have to think about together. Students, and I want to do the scores. Wonderful. If I've not put the order function. Order function. So if we do this, there's a comma there. If I do this and look at how it has sorted the score, you can see that now 85, 88, 90, 92, 90, it has sorted now by scores, okay? But this is, both of these are actually in ascending order, which is the default. Sorry. This is in ascending. This is in ascending as well, okay? But how can I do this in descending, okay? This is a vector. And it's just one tiny item that we need to add. You can just come and say, inside here, I just want this to be, I just negate students underscore, student $ scores. If you do this, this one gives you in descending order. In descending order. Let's run that line and we see. So at least we expect now in line 107 that the scores of that data frame will now be in descending order, okay? And it's true, because now it has, and I hope you remember this strategy that we used in the in the vectors. We can do this. So you can see now our data frame now, if you access sorted by scores, it will always give you scores that are sorted in descending order, and etc. Okay. So there are many operations, but I just wanted to give this brief overview of how we can actually do some operations in the data frame and for vectors, and why it is very important to grasp those concepts of vectors and matrices and vectors, because in the next class that will be covered by Ludovic, he will use this concept. So there will be no time to go back to these concepts again. So he will just hit the ground running and go to data frames. Okay. Then we talked about how, since now we have students, our data frame, how can you remove some of the elements? Removing some of the elements of the data frame. How can you do this? So what you can just do, which one do you actually want to remove? You can just say, students, I want to access, maybe I want to remove grades. Grades are no longer important in my data frame. Then what you do, you just assign it to null, like that. Okay. If you access or you assign that column to null, what it does, it actually removes that column, which is called which is actually called grade. And if I run the students, you can see now in our new data frame, there is no grade. Grade has been removed. Okay, that is one way that you can also do this. And in other ways that maybe, okay, maybe let's see, you want to not to access, let's sorry, you also want to actually remove age. Okay, age, maybe for, yeah, let's see what this give us. Student is age there. Let me try this. Okay, that won't work. But that's just another way of removing columns or elements of a given data frame. So up to that point, I don't know whether there's a question with that simple review of data frames. So if there is no question, so what I'll do, I can just give you, I don't know whether it will be possible to paste it on the chat. Is just another, again, a simple data frame that is called employees. You can play around with it. I'll paste it in the chat. You can play around with it and try to at least replicate what we have done today. It's just a simple data frame. Again, it just consists employees' names, IDs, their name, the department. Okay. I know Ludovic will cover this factor next time, but we will also talk about next time. It also has dates. These employees joined the company, and also have probation. That is whether you're on probation or not. Just play around with that simple data set. But the most important thing, before you even go to complex data sets, first of all, understand these basic data sets. Okay, it is very important that you get the concepts of these small data sets, because the same concept will just be applied when the data set scales up. So with that, I think I'll stop there for today. But in case you have any question, please feel free to write to us in the R for Fun Club session, and we will get back to you. Okay. Otherwise, I hand it back to Mary J to close for us. Thank you.
Thank you very much, Duncan. Thank you for that very elaborate explanation and taking everyone through the basics again and through the last course. I'm really happy for this session because you feel free to ask your questions, just keeping in that, like, there's no question that is too small or no question that is too big. Just start a discussion and input your questions, and any of the facilitators are going to get to you. So next week we are going to have session 2 to be led by the facilitator Ludovic, Dr. Ludovic, and we are hoping to see you all there. For now, I think we can call it a day. Bye-bye.
Okay, bye all, and keep practicing. See you next week.